In problem 20, we're going to find the real imaginary parts, but not in terms of x and y. We're going to find them in terms of r and theta. So that is, if we write z is r cosine theta plus I r sine theta, or even we can put parentheses around the cosine and sine. What are the real and imaginary parts? Now, there's a couple ways of going about this. Firstly, we wouldn't want to just plug in z as r cosine plus I sine because we have some division happening, this reciprocal second term happening. And so it's going to just be a little bit clunky if we do that. Let me just notice something though, that exponential form helps us pretty seriously here. So if we write z as r e to the I theta, where e to the I theta is this cosine theta plus I sine theta, then whenever you write that, 1 over z, or whenever you need to do division, this expression is helpful because 1 over z is now 1 over r e to the I theta, which we can write as e to the negative I theta over r. And then we can go back and we can plug in terms of cosine and sine. But this expression is going to help us really deal with this reciprocal term. So how can we write it in terms of r and theta? Well, we can first use exponential form. And from our side work over here, this is what our exponential form is. Let me just put a separator there. And now that there's no really funny business about the things in the denominator besides this 1 over r, but the 1 over r is okay, we can go in and we can use the relationship between e to the I quantity and then cosine and sine. So this is going to be r cosine theta plus I sine theta, and then plus 1 over r cosine of negative theta plus I sine negative theta, because it's a negative theta on the I for this guy. Now, cosine of negative theta plus I sine negative theta, that's e to the negative I theta. That's just the conjugate of this guy, actually, because if I go theta counterclockwise around the circle, and then I conjugate, that's the same as going negative theta. I just flip over to the other side. But nevertheless, if you don't like that, we can also use the fact that, let me actually multiply the first expression out. We can also use the fact that cosine and sine are even functions, or sorry, cosine's an even function and sine's an odd function, to rewrite this expression as cosine theta minus I sine theta. So if you don't like the conjugate explanation, we can use the even and oddness of them. So we'll have to multiply our 1 over r in now, and let's do it. Let's multiply it in and collect terms in one go. So we're going to have as our real part from the first guy r cosine, and our real part from the second one 1 over r cosine. And then what's our imaginary part? Let's see. Our imaginary part is r sine for the first one, and then for the second one it's going to be negative 1 over r sine, which we can even simplify a little bit more. We're going to get cosine r plus 1 over r, r plus 1 over, oops, let's just do some quick side work. R plus 1 over r is r squared plus 1 over r. So we're going to get cosine squared times r squared plus 1 over r. And then plus I sine, can pull out that sine, and then we're left with an r minus 1 over r. So that's going to be r squared minus 1 over r. Okay, so what's our real part? So our real part of this f, which we are writing in terms of r and theta, is cosine times r squared plus 1 over r. And our imaginary part is, again, v, but now it's a function of r and theta, is sine theta r squared minus 1 over r.